Welcome to section 9 in our exciting journey to learn the Go language. In the previous section, we dug deep into how Go interfaces with databases. In this section, we will cover another practical aspect of Go programming, which is how to communicate between applications using the Go language. In this section, we'll cover TCP communication by exploring how to write TCP clients in Go, and then how to write TCP servers in Go. And then from there, we'll cover UDP communications. And then at the end, we'll explore the popular protocol buffer message format, which is used in communications in modern software. Now, we move to the first video of this section, which is TCP communication clients. Let's get started. In this video, we'll start with a quick overview on the TCP protocol. Then we will move to discuss the net package, which is Go's golden gate to IP layered communications like TCP and UDP. Then we will conclude by writing some code to implement a TCP client in Go. So what is TCP? TCP is a very popular transmission protocol used to transmit data reliably from one point to another. It is one of the core components of the internet. We not only use it for the World Wide Web, but also to transfer files and emails and messages of all sorts. TCP communications use what is known as sockets, which are IP addresses combined with port numbers. And we'll cover sockets in more details shortly. TCP is a reliable, ordered, and error-check protocol. It performs handshakes between the transmitter and the receiver to ensure the data was received and accepted on the other end. So you can see the receiver sends acknowledgements as it receives data, and then when the connection gets closed, the transmitter sends an acknowledgement. This technique, however, causes some latency due to all the checks that happen in between the transmitter and the receiver. However, it is typically a small price to pay if the transmission needs to be very reliable and ordered. By ordered, I mean messages are received on the same order by which they were sent. For more information on TCP, please have a look at the Wikipedia article at n.wikipedia.org/wiki/transmission_control_protocol to build a better idea on the TCP protocol. It's not a small topic, however, it is a vital concept to understand for advanced and modern software. In Go, to communicate via the TCP protocol, we use the net package, which is a standard package that Go offers for IP communications. The IP protocol is the underlying protocol to TCP and UDP, so you can think of it as the building block. We did use net package in the past to build the Hydra chat server in videos 5.4 and 5.5. So to initiate a TCP connection, we simply use net.dial. As shown, the two arguments to net.dials would be the protocol name, which in our case in this video would be TCP, and the address to which we're trying to connect. So the address to which we're trying to connect is in the form of a socket. So as mentioned earlier in the video, a socket is an address or an IP address combined with a port number, and we separate them by the column. This will give us a connection object, which we can then use to read data and write data. On the other hand, to listen for an incoming TCP connection, we use the net.listen call, which takes arguments, the protocol type, which is in our case TCP, and the socket address, which in our case, if we're listening to a local socket in our server, we just indicate the port number and the column. So this is a socket address at which we want to listen. So before we dive deep into the code, let's discuss the stages we go through to write a TCP client and a TCP server. For the TCP client, we start by calling the net.dial function to establish a connection, which returns a CON interface that implements both I/O reader and I/O writer, and in turn exposes us to all the popular read and write methods that are supported by many Go packages. And then at the end, we close the connection when we're done. So again, we dial, get the connection, then read write to the connection, then we close the connection. Now at the server level, we start by calling net.listen to listen to incoming connection. And this returns a listener interface, which is an object we can use to accept incoming connections when we receive them. And the accept will then return a CON interface again, which we can use to read and write as before, then close. So to summarize, at the server level, we listen to connections, then we accept connections when a client dials, then we read or write to the accepted connection as we please, and then at the end, when we are done using the connection, we close it. Perfect. So let's dig deeper into the CON interface. The CON interface represents an active IP connection between a client and a server. It supports the I/O reader interface as well as the I/O writer interface as shown. And this is done by implementing the read method and the write method. It also supports a closer interface, which closes the connection. And between those three interface methods, the CON type gets the support of most of Go's popular packages, like the FIMT package, for example, which has very heavy support for the reader interface read method and the writer interface write method, as well as the buff.io package, which also has support for those methods. The read method and the write methods are what we use to send and receive data over the IP TCP connection. The CON type also supports a method called local address, which is used to get the local address of the connection, and a remote address method, which is used to get the remote address that's trying to connect to us. The CON type also supports three methods that can be used to set a timeout on the connection when there is no activity in reads or writes or either. So that would set a timeout on either a TCP read or a TCP write. This method will set read timeout on the TCP connection, and then the set write deadline method would set a timeout on the writes on our TCP connection. Those methods are very helpful because they help us get rid of stale connections and ensure our resources are not overused in a production environment. Now, under the hood for TCP connections, the CON interface is implemented by the TCP CON type, which exposes methods that handle the concrete TCP connection features. However, most of the time, we would typically use the CON interface directly if we don't need to use advanced features of the TCP connection. It's also important to point out that the CON interface supports concurrency, which means multiple Go routines can use it at the same time. So as mentioned earlier in the video, the dial function is what we use to initiate a connection between a client and a server, or a sender and a receiver. The first argument to the dial function is our network protocol, which indicate whether we would like TCP or the TCP version 4 or TCP version 6 or UDP, etc. as our protocol. So this argument would be the deciding factor of the concrete type which the CON interface will implement. Then the second argument to our dial function would be the socket address to the receiver we're trying to connect to. So a socket is, as mentioned earlier, an IP address, then a caller, then a port number. And IPv6 is also supported, which is the new generation of IP. We can use protocol names here as port numbers. So HTTP is port 80, and we can use DSN website names as our addresses because they translate into IP addresses. And as mentioned earlier, if we're either dialing or listening to a local connection, we don't need to specify the IP address, we just specify the port. So the dial function ultimately returns the CON interface as well as an error object type, which would be nil if no errors occurred. Dial typically picks a randomly available port from the client machine to establish a connection to the defined address and port numbers at the server machine. Meaning that when we call dial this way, this address would be the server address we will connect to. However, the client address from which we're connecting will be dynamically selected. Another nice function that should be mentioned is the dial timeout, which is very similar to dial, except that it adds a timeout. So that if we are unable to connect from a client to a server or a sender to a receiver, then the function would fail and return within the specified timeout. Now it's time to write some code. So let's create a folder called Hydra Comms, which would be underneath the Hydra folder in our Go source folder. And then in the Hydra Comms folder, we'll create a file called Tcp Communications.go. In there, we will write a TCP client which will take a message from a user and then send it out to a TCP server. And we'll also write a TCP server at the end, which will listen to the incoming messages from our client and respond accordingly. So we'll start by declaring the main package as shown, since our entire application will reside in here. And then we'll start to import a bunch of packages which we'll use in our code. So notice how we imported the net package here, which our main entry for TCP IP code. For the rest of the packages, we'll see how they're utilized as we go. So we'll start our main function by defining a bunch of flags, which we would need the user of our program to provide to us. If you need a refresher on the flag package, you can have a quick look at the flag package page in the golang.org website. So for now, we'll create 2 flags of type string. So that will be done by calling flag.string. The first flag would be called type, which would dictate whether we are currently running as a server or as a client. That would be either a TCP server or a TCP client. And then our second flag would be the address, which would be the address to which we're sending data in case of a client operation, or the address at which we're listening for incoming data in case of a TCP server. We then do flag.parse to obtain the provided flags. And then we convert the provided user flags to uppercase letters so that we can compare against them easily. So we will use a switch case to compare and identify the type flag that the user provided. So if the user provides an S, then we call a function called runServer, which is where we will write our TCP server code. Otherwise, if the user provides a C as the type, then we will call a function called runClient, which will act as our client code. So both functions will take the address string as an argument. And if you're wondering why we dereferenced the address variable, that is because the address variable, which is provided by the flag.string function, is of type pointer to string. So we need to dereference that pointer in order to obtain the actual string value represented by the pointer. Now let's look into the run client code. So the first thing we would do is to call net.dial in order to establish a connection to a TCP server on the other end. Our protocol would be TCP, which is our first argument to net.dial, and the address we would use is the address provided by the user. Now this will return a connection object as well as an error object. If the error object is not nil, then we return the error object as shown. Otherwise, if we get to that point of the code, then we know that the connection has been successful, and the con object here does indeed represent working TCP connection. So we defer con.close to ensure that the connection gets closed and resources gets cleaned up when we're done with run client. Now, next thing we do is to use a buff.io package to create a new scanner and have this new scanner tied to the standard input. And that's why we needed the buff.io package and the OS package. So building a scanner on top of the OS standard input will allow us to be able to read user input in real time, and we'll see shortly how that works. Now that we have a scanner ready, we will print a message to the user asking what message would the user like to send to the TCP server. Then we will call scanner.scan, which will scan the OS standard input in real time, and then whenever the user would input a string and hit enter, the loop will iterate and we will get inside the for loop. So the first thing we do here is identify that we captured the user's input by printing out the message captured in our scanner by calling scanner.text. Now, in order to write to our connection stream, we can simply use the con.write method, which takes a slice of bytes as an argument. So our slice of bytes would be the combination of the user message captured in our scanner in bytes by calling scanner.bytes and the /r symbol, which represents an end line. Now what we do after that is create a buffer of bytes, which we will use to host the reply message from the server. And then we will call con.read, and the buffer will be the input argument for con.read in order to read the incoming message on the TCP connection. Now, if we detect any errors, and at the same time the error is not end of file, we log an exit using log fatal. However, if error is io.eof, which stands for end of file, then we know that something closed the connection. And in this case, we wouldn't consider it as an actual error, but we would just print the fact that the connection was closed, probably by the server, and then we'll return nil. Now, if there are no errors, we would get to this point of the code, and in here, we would just print out the reply from the server. And that is done by simply typecasting the buffer, which hosts the data received from the server, to a string, and then printing all of that to the standard output. Then at the end, we return scanner.error. So type scanner supports a method called error, which indicates if there were any errors observed during the scanning process. If no errors occurred during the scanner.scan process, then the scanner.error will just return nil. And with this, we wrote our TCP client. In this video, we started our journey into TCP communications by first a brief definition of TCP. Then we implemented a TCP client